Solar and lunar eclipses are fairly rare events, which can of course be visually spectacular, but they don't have anything to do with the weather. However, there's a type of eclipse that does have a weather connection. These so-called satellite eclipses are fairly common. In fact, there's one tonight. Now, if you look closely at satellite loops this time of year, you might notice the consequences of a satellite eclipse. It's a jump in the animation caused by a short period of missing data. This happens because satellites are primarily solar powered, and during a satellite eclipse, the Earth comes between the sun and the satellite. So the solar panels can't power the instruments. The onboard battery doesn't have enough capacity to last the entire time the satellite's in the Earth's shadow, so imaging operations have to be suspended for a while. Not all satellites have this problem. Only the geostationary ones, which are parked over the equator and orbit at the same speed as the Earth rotates. This type of satellite sees the same view of the Earth all the time, which is great for making loops. Now, since Earth goes through a full rotation once per day, it's logical to think that satellite eclipses would happen every night, because a satellite over the equator would have to be in darkness at least a few hours daily. And that would be the case if the Earth weren't tilted on its axis. To see how the tilt makes a difference, consider the situation in late June on the first day of summer, here when the northern hemisphere is tilted toward the sun, which is directly overhead at the Tropic of Cancer. Notice that even when the satellite is on the nighttime side of Earth, it's still in sunlight because the tilted axis skews the orbit. But now let's move ahead 3 months to the autumnal equinox. At that time, the sun is overhead at the equator. So as the Earth rotates, a satellite right over the equator must be in the Earth's shadow, at least for a short time each day. And this same geometry also applies around the first day of spring, the vernal equinox. So there are 2 eclipse seasons each year. They begin in earnest about 3 weeks before the equinoxes and last until about 3 weeks after, with the longest stretches of missing data about 2 to 3 hours long occurring right on the equinoxes. The good news is that the eclipse periods occur late at night, generally between midnight and 3 a.m. local time, when fewer people depend on the data. Still, nobody likes missing satellite data, and the newest generation of geostationary weather satellites has a larger battery, so they won't necessarily have to shut down during the eclipse periods. These newer satellites are already in orbit and will be phased in over the next few years as the older generation is retired. Paul will be back with the extended forecast next.